Fourth grade lesson 8.5, problem solving, comparison problems with fractions. Let's put our fraction knowledge to the test. Our essential question is, how can you use the strategy draw a diagram to solve comparison problems with fractions? The deepest part of the Grand Canyon is about 1 1/6 miles deep. The deepest part of the ocean is located in the Mariana Trench in the Pacific Ocean. The deepest part of the ocean is almost 6 times as deep as the deepest part of the Grand Canyon. About how deep is the deepest part of the ocean? Well, here's what we're trying to find out. What we know is that the deepest part of the Grand Canyon is 1 1/6 miles deep, and the deepest part of the ocean in the Mariana Trench is 6 times that amount. 6 times that amount. All right, what do I need to find out? How deep the deepest part is. I'll just put how deep the deepest because that's what fits. What information do I need to use? Well, we know the deepest part of the Grand Canyon is about 1 1/6 miles deep. The deepest part of the ocean is about 6 times as deep. And I can multiply, because they said times anyway, right? 6 times as deep to compare the depths. Oh, I guess I could draw a diagram to compare the depths too. We'll draw a bar model, compare the depth of the deepest part of the Grand Canyon and the deepest part of the ocean in miles. We have 1 1/6, and we have 6 times that amount. So we have 1 1/6 here, 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 and 1 1/6 here for the deepest part of the ocean. This was for the Grand Canyon, and the other part was for the deepest part of the ocean. 6 times this amount. 1, 2, 3, 4, 5, 6. Visual of that. Write an equation and solve it. Well, m, this unknown number that we don't know, is the variable we're going to give to the deepest part of the ocean in miles. I guess that's why they used m, is because miles. And we know that m, whatever it is, the deepest part of the ocean, is 6 times that of the Grand Canyon's deepest part, 1 1/6 miles deep. We need to change this mixed number into a fraction so that we can multiply it. And in order to do that, we do the 1 times 6, which is 6, plus 1 more is 7. Hopefully you're feeling much more comfortable with that step now. Oh, times. Okay. Now I can do my multiplication. 6 times 7 is 42. And my denominator remains a 6. Now I just need to write the fraction as a whole number or a mixed number if I need to, but they're saying a whole number because 42 divided by 6, if you know your multiplication facts right off the bat, you recognize that is 7 exactly. 7 times 6 is 42. So 7 is how many miles deeper? So the amount of miles deeper, the deepest part of the, not amount of miles deeper, sorry, the deepest part of the ocean is about 7 miles deep. That's way in there. Let's try another problem. Mountains are often measured by the distance they rise above sea level. Mount Washington rises more than 1 1/10 miles above sea level. Imagine trying to climb upwards 1 1/10 mile. Mount Everest rises about 5 times as high. Oh, I'm tired just thinking about it. About how many miles above sea level does Mount Everest rise? This is what we want to find out. I need to find Mount Everest height. What information do I need? I know that Mount Washington is 1 1/10 miles high, and that Mount Everest is 5 times that amount. How will I use it? I can draw it, or I know that it's times, so I can multiply it. We'll do both just so that our brains are connecting to both. I'm going to have Mount Washington's amount, which is 1 1/10 mile high. And then for Mount Everest, because it's 5 times that amount, I'm doing 5 of those. 1, 2, 3, 4, 5. 1 1/10 on all of those. Sorry, that's kind of squashed in there. You get the idea. And what we're doing is 1 1/10 added to each other 5 times over. So we could really do that as 5 times 1 1/10. Remember, I cannot really multiply the mixed number. I have to convert that into an improper fraction so I can then multiply, change everything to fraction. 1 times 10 is 10, plus 1 is 11. That is 11 tenths. And we're multiplying that times 5. 5 times 11 is 55. And our denominator remains the same, 10. Okay. Now, this is an improper fraction, and of course, we always want to try and change our improper fractions back into a mixed number for our answer, so our brains know exactly how much we're talking about. We do that by dividing. That's 55 divided by 10. Obviously, 10 times nothing gives me 5, or right below. 10 times 5 gives me 50. With 5 left over, that's 5 out of 10. So my answer is 5 5/10 of a mile. Reducible, simplifiable, by the way. These can be reduced, but we haven't been reducing at this point in time in these lessons, so I'm going to leave that piece out, let your brain digest the rest of it instead. So Mount Everest rises about 5 5/10, or 5 1/2 miles above sea level. How did drawing the diagram help you solve the problem? Well, maybe it didn't. Maybe you're understanding the multiplication piece so well that you didn't need it. But if not, then you get a visual about what you need to do. Sometimes, as we're learning things, we need the visual about what we're needing to do, and that becomes helpful to us. Let's look at number 1 on the Sharon Show. Komodo dragons are the heaviest lizard on Earth. A baby Komodo dragon is 1 1/4 feet long. Wow, they're big. When it hatches. That's a baby? Oh my goodness. Its mother is 6 times as long. How long is a mother? Well, first we're going to draw a bar model to show the problem. We have the baby 1 1/4 foot long. 1 1/4 foot long. That's pretty long. And the mama is 6 times as long as the baby. 1, 2, 3, 4, 5, 6 of those 1 1/4 put together. I can add 1 1/4 plus 1 1/4 plus 1 1/4 plus 1 1/4 6 times over. Or I can do it as an equation of multiplication. I'm taking 6 times 1, 2, 3, 4, 5, 6, this 1 1/4. Now I do need to, now that I need to multiply, I know I need to multiply. I do need to convert this to an improper fraction. 1 times 4 is 4, plus 1 is 5. So that's going to really be 6 times 5 fourths. Now I can multiply 6 times 5, which is 30 fourths. This is an improper fraction, so now I just need to do my division to put it back into mixed number form. 30 divided by 4, well, what number times 4 will get me 3 or below? Nothing. And what number times 4 will get me as close to 30 as possible? 7 will, because 7 times 4 is 28. Nothing more than that. I have to borrow, and I get 2 out of 4. Reduce, that would be 1/2, but we'll leave it as 2/4 for now. 7 2/4 feet long. 7 foot long lizard. That's taller than me. Oh my goodness, by a lot. It's like a basketball player height lizard. Number 2 says, what if a male Komodo dragon is 7 times as long as the baby Komodo dragon? Holy lizards, Batman. That's crazy. How long is the male? How much longer is the male than the mother? Well, we know that the male is 7 times the baby, and the female was only 6 times the baby, and that one time was a 1 1/4. So daddy is 1 1/4 feet bigger, or longer, I guess, than mama. And how many feet is he? Well, we already calculated mom's length, 7 2/4. So we have the choice, if we want to, of just adding the 1 1/4 more because mama was 6 and dad was 7. That's one route you can take. And you would get, it's a good reminder for adding, since we've been multiplying now, how to add fractions. We can do the fractions first. We can line them up this way. It's sometimes easier, I think. Let me just move them to be vertical instead. Start with the fractions first. 2/4 plus 1/4 is 3/4. No carryover necessary. 7 plus 1 is 8. That was one approach you could have taken. Or you might have said, "Ooh, I just rather multiply with fractions." And you'll probably get to that point if you're not there already, that you're more comfortable multiplying with fractions than adding with them. And instead, I'm going to take baby's 1 1/4 feet and multiply it by 7 because daddy is 7 times longer. And we would get, we already know that this is 1 times 4 is 4 plus 1 is 5. Oopsie. 7 times 5 fourths. That's 35 fourths. 7 times 5 is 35. Divide 35 by 4 to get it back into its mixed number. No, that doesn't work. This is going to be 8 because 8 times 4 is 32. And I have 3 out of 4 left over. Ta-da. Either approach works. You're going to find in math that people will take different paths to get there. As long as they understand what's happening in a scenario, they're going to find a tool that gets them there. So 2 ways. You could have just added on to mom's 6 times more because dad was just 7 times more. We could have just added it. Or we could have said, well, okay, 7 times that. And there you go. And now that I'm very disturbed by an almost 9-foot long lizard, let's see what else I can learn. The smallest hummingbird is the bee hummingbird. It has a mass of about 1 1/2 grams. A gram measurement, 1 gram measurement is like similar to the weight of like a paper clip. Tiny. So this is 1 1/2 grams, like a paper clip and a half. That's really small. A rufous hummingbird's mass is 3 times the mass of the bee hummingbird. What is the mass of the rufous hummingbird? So I have the bee hummingbird, that's how I'm going to abbreviate it, is 1 1/2 grams. And the rufous hummingbird is 3 times that amount. So 1, 2, 3 times that amount. 3 times the 1 1/2. Change this to an improper fraction. 1 times 2 is 2, plus 1 is 3. That's going to be 3/2. So here is the equation rewritten from this to this. Multiply. 3 times 3 is 9. Convert. 9 divided by 2 will give me back into a mixed number format. 2 times 3 is 6. 2 times 4 is 8. That fits. That's as close as I'm getting, though. And 1/2. 4 1/2 grams. 4 1/2 paper clippy weight. That's still pretty tiny anyway. I mean, they look like a little bug, I would think. All right, one more. Sloane needs 3/4 of an hour to drive to her grandmother's house. It takes her 5 times as long to drive from her to her cousin's house, much further away. How long does it take to drive to her cousin's house? Go ahead and pause and try this one. See how you do. All right, so I have, this is not going to be Sloane. This is going to be Grandma's house. 3/4 of an hour, 45 minutes, right? 3/4 of an hour. And to get to cousin's house, that is a slang spelling for cousin. I probably shouldn't do that. Let me just put the correct spelling. There we go. 3/4 for 1, 2, 3, 4, 5 times that amount. 3/4, 3/4. That's the visual part of it. A lot of you are probably at this point skipping the visual part of it. That's fine. You're going to take 3/4 and add it together 1, 2, 3, 4, 5 times, or simply multiply 5 times 3/4 because, as you well know, multiplication is a shortcut for repeated addition. Then we're already a fraction. We are not a mixed number here, so skip the conversion step. 5 times 3 is 15. 4 is the denominator still. Now we are an improper fraction, meaning whatever this is, it's more than 1. There's more than 4/4 there, right? There's more than one. So we'll just convert it. 15 divided by 4. 4 times 4 is 16, which is too high. So 4 times 3, I did that 0. I kind of skipped that step. You'll start doing that if you haven't already. And then 4 times 3 gives me 12. 5 minus 2 is 3. 3/4. So her cousin's house takes her to get there takes 3 3/4 hours to get there. That's a long drive, long time to be in the car. The math on these, the calculations on these, I know you're pretty solid at by now. It's just the practice of reading these problems and translating them into what you need to do for math. Read it, reread it. You might have to read it a couple times to understand it. Don't just panic and think that you can't do it just because words. You can do it.